Okay, let's try to prove that 1 upon root n, the sequence 1 upon root n tends to 0. First of all, what I want you to understand is whether this sequence is monotone or not. Let's try to see that. Monotone. Whether this sequence is monotone. Now, whatever term you will have, root n, okay, any term root n is less than or equal to root n plus 1, right? This will happen for all natural numbers, right, for all n. So that would mean that 1 upon root n plus 1 will be less than or equal to 1 upon root n, okay, just by the simple relationship of real numbers, right? Okay, so that means that this is term an, this is term an plus 1. So what do we have? We have that an is greater than or equal to an plus 1 for all n in this sequence. So what does that imply? That implies that this is a decreasing sequence. So yes, we have found out that this is a decreasing sequence for all n greater than or equal to 1. Okay, so this will be a sequence like, you know, starting with 1 upon root 1, then 1 upon root 2, 1 upon root 3, and so on and so forth. So monotone, yes, so it is a monotone sequence. Now what about boundedness? Whether this sequence is bounded or not. So let's talk about boundedness of this sequence. Now you have a term 1 upon root n. So this term will always be greater than 0. Okay, it will always be greater than or equal to 0 for any n greater than or equal to 1. This will be greater than or equal to 0, and it cannot move beyond 1, right? It cannot move beyond 1 also. So it will be between 0 and 1. So what does that mean? That means that this is a bounded sequence. That implies boundedness. Okay, so that implies boundedness. So boundedness, yes, it is bounded. So these two things actually imply that this term, this sequence an would definitely converge to some a belonging to the real numbers. Okay, now 1 upon root n tends to a. Okay, now which implies 1 upon root n multiplied by 1 upon root n should tend to a multiplied by a by the algebra of limits. Algebra of limits. Okay, so that would mean that 1 upon n tends to a square. Okay, 1 upon n tends to a square, but what do we know? But we know that 1 upon n tends to 0, right? 1 upon n tends to 0, which implies that means because the limit has to be unique, a square equals to 0, which means that a equals to 0, and hence 1 upon root n actually tends to 0. Okay, so that's how you can prove that 1 upon root n actually tends to 0, same as 1 upon n.